Hello everyone, October 18th. Let's do this easy question. Let's see how fast we can get this done. I have an appointment today with DMV, so the entire afternoon will be gone. I feel very sad, but I have to do this. I've been driving illegally for a while. Alright, let's take a look. Given the root of a binary tree with unique values and the values of two different nodes of the tree x and y, return true if the nodes corresponding to the values x and y in the tree are cousins, or false otherwise. Two nodes of a binary tree are cousins if they have the same depth with different parent. Okay, two nodes are cousins if they have the same depth, but with different parents. Note that in binary tree, the root node is at depth 0. The children of each depth k nodes are at the depth k plus 1. The children of each depth k node is k plus 1. Okay. Alright, so each value is unique, right? Unique values, and there are two different nodes that are given two different nodes. We want to know if they're cousins. So 4 and 3, they're not, because they are not on the same level, right? So it has to be same depth, I mean the same level, but with different parent. 5 and 4, they are, because they're on the same level and different parent. And 2 and 3, they are the same level but have the same parent, so that's not good. Okay, so blah blah blah, each node is unique, x not equal to y, they exist in the tree. Okay, so what do we do about this? Well, we're talking about same level, so breadth first search, BFS, and we go level, so BFS, and what we can do is when we append, right? When we append, if they comes from the same parent, so we append them. I can say append them as a tuple, right? Is that possible? We append them as a tuple, and as we go through everybody, so a tuple, a tuple, a tuple, and then when we pop them out, we want to see if a set. No, it's fine. Just do a list. It's fine. Just do a list. A list or tuple, it doesn't matter. There's only two, so check-in is fast. So we're going to check every time we pop out. We're going to check to see if x is in it. If x is in, it has to be in one of them, right? So, well, if x is in it or if y is in it. If x or y is in it, if both are in it, then that's a false. And if one of them is in it, then we record it, and then we wait for the other one. What we can also do is we check, and then we note the, okay, know the index, right? Index. So as this list come out, we have the index, and we can say the index that x is in and the index that y is in. And then once we're done, initial index will be -1, and then we go through everything, and then if after we go through they're positive and they're equal, that's a false. If they're positive, they are not equal, then that's a true. And if one is positive and the other is a negative, which means one of them is not found on the same level, that's a false. Okay, so I think that shall be sufficient. All right, let's get this one done. Muy rápido. Yeah, we need to. Oh, again, it's a tree, so we don't need to write test cases. tree node. We're gonna do a q, right? Q equals this. Put a root in it. Oh, actually, the way that we're thinking about it, we're gonna put this in it, right? Actually, root.val in it, and then we just say while q temp equals this, and for I v in q. Ooh, that's not v, it's v list in q, right? And then I'm gonna say xi, yi, both start with -1. And say if x in v list xi equals I, if y in v list yi equals I, right? Once we're done, I'm gonna say if xi larger than 0, larger equal to 0, and yi larger than equal to 0, we're gonna return xi not equal to yi. Otherwise, if 1 larger than 0, so if xi larger than 0, I'm going to say if xi times yi is smaller than 0, smaller equal to 0, so one of them is negative, then return false. If both are smaller, which means we didn't find, we'll just keep going. And we also have to do, oh, I cannot do that, I have to go to node. What are you thinking, man? It has to be node, so it's node list. It has to be node list. I don't like this. I don't like this. So we have to create, oh my god, node list. Let's say for node, in node list, right? If x equals to node.val, then we do this. Then same with this. If y equals, we have to use node, otherwise it won't work. And so we check the node, and then we're gonna do the left and right. And we say if node.left, right, temp.append new node list. Man, I feel like it's so convoluted. New node list equals this. If node.left, new node list.append. Can we do this easier? I don't like it. I don't like it. It's very convoluted. I don't like it. Let's just, because it's unique, right? It's unique. So we record the parent. We can record the parent. Yeah, we can record the parent. So one number of nodes 1 to 100. Yeah, I will record the parent. So and start will be parent. I'm gonna say 0, right? And then the parent. So xp and yp. Yeah, let's do the parent. And then I don't have to do this. I can just say for I and for parent and node, right? And then we say if node.val is equal to x, then x parent is going to be p. If node.val is equal to y, and then y parent is going to be p, right? And after that, we're going to say if node.left, then temp.append. Well, parent is node.val and node.left, right? And if node.right, temp.append, same thing, node.val and node.right. And same thing, after we go and we say If both are larger equal to 0, that means we found it, and then they have to be different. Otherwise, if it's smaller, so one of them is not found, but the other one is found, then it's false. Otherwise, we keep going, we say q equal to temp, and go up, and because they definitely will exist, right? They definitely will exist. So we don't have to return at the end, but let's just return false at the end. So it doesn't really matter at the end. Okay, so do this. Test case. All right, let's run it. xi is not defined because there's no more xi, it's xp. I'm talking about parent. Parent. Okay, try it again. Okay. Let's try some. We have all these cases. How about a single? Oh, we have to. Oh, a range of 2. We have to have 2 nodes. I have confidence. I think this one should be good. Let's go for it. Yep. 472. 36 milliseconds. So, I'm just copy and paste this back because we made some changes. So, standard, it's pretty standard, right? So we say standard BFS solution, right? BFS solution. The only trick is to include current node's parent, when pushing it into the next queue, Then whenever x or y is encountered, we record its parent. Finally, we compare the parent. If both x and y are found on the same level, right, and their parents are different, we return true, otherwise false. If only one of x and y is found, we immediately return false because that indicates that x and y are on different levels. Finally, there's no finally, right? So on, because each node is visited once, and 36. Let's take a look. So 36 milliseconds. So the 52 ranking. All right, let's see. Here, what's this method? And too long, way too long. Oh, look at this. It's like 12 milliseconds. DP. Left and right, and DP val, depth and parent. Depth is cousin. Wait, what does one do? It just depth. Depths, This is BFS. The val equals this and this. Oh, we record the parent of every single node. Okay, I see what this one's doing. And this is a node. What's a 0? 0 is what is 0? x is value, right? 0 is depth of depth and parent. So we record the depth and parent of each one. Okay, that's fine. That's fine. And then we check this. Let's probably have. Yeah, it's fine. All right. Solution is a no-go. 993. Level order traversal, BFS. Oh, DFS. So we return. What does DFS do? If not null, return this. If no val equal to val, return depth and parent. And we return this, a left or right, and then we do x and y and okay. All right, that shall be it. This is what's 993, right? 993. Okay. All right, so we have time. Let's roll another one. So this one's done. Let's go a medium. All right, let's pick one. Come on. Sum of even numbers after queries. I don't think I've done this before. Nope. Okay. Sum of even numbers after queries. You're given an integer array and an array queries where queries I equals val and index. For each query I, first apply nums index I equals nums index I plus, so we add the val, then print the sum of the even values of nums. Return an integer array answer, where answer I is the answer to the ith query, okay? So 1, 2, 3, 4 query. So first do is nums index, so nums 1, 0, 1 equals this, so it doesn't change. Wait, it does change. Our value is 1. So we add 1 to a position 0, so it becomes 2, 2, 3, 4. And we add all the even numbers. That's 2, 2, 4. And then position 1 within -3, so within the -1, so that's 2 plus 4 is 6. Position 0, -4, -2. -2 is still even number, so okay. And the last one is position 0 into 3. Add 2 becomes 6. Then the sum of this and this. Ooh, it's a very interesting question. I actually like it. Okay, so let's write it out. We have 1, 2, 3, 4 to start with. We can compute its current sum, right? Even number sum is 6, right? Haven't started. Now, first one come in. We say we add 1 to position 0. So we see position 0 is a 1, is an odd number, which means it's not being included in the previous. So we change it. So now it becomes 2, 2, 3, 4. But we don't compute. We compute based on what we had previously. So previous is 6, right? Now an odd number turns into an even number. So we have to add this even number. So it becomes 8. Then next one is -3, 1. So position 1 in turning to an even number, -3, so it becomes -1. So that is an even number taken away. So we have 2 minus 1, 3, 4, which will have a 6. Go back to 6. Next is a -4, 0. So the first value we're going to add a -4, which turns into a -2, right? So it's from even number turns into an even number. So we're going to minus the previous one, add the current one. So 6 minus 2 is 4. minus 2 is 2, so now it becomes 2. And finally, we have 2, 3, 0, 1, 2, 3, 3 position at 2. It's an even number, and the result is an even number. So what we're going to do is 2 minus 4 and plus 2. 2 minus 4 plus 2. No, not plus 2, plus 6. Jeez, plus 6. Can we like do the delta? Let's do delta. So minus 4. So like 2 and 4, right? The delta is 2. And 4 is even, and the delta is an even. So we add it. So that'd be 4. And if previous is an odd, and now I add an odd, think about this. No, we still have to analyze. We still have that previous. If previous is even or odd, and the current value is even. So if previous is even, so we have even, right? Previous, the value is even, and the delta is also even. In that case, we just add delta. If previous value is odd, delta is even. Odd plus even is still even. So in this case, we ignore. If previous is even and then delta is odd, we have to remove the previous even. If previous is odd and delta is odd, then we need to add both to it. So that's the 4 situations. All right, let's try this. We say this is going to be 984, 980, 85, 95. $985. All right, this is 985. Okay. Oh, and then copy and paste. Nope. How do we do this? VG. Oh, VG is going down. Oh, hold on. Again. It's VG5. Nope. G5. Nope. 5G. Nope. Hold on. GG5. No. 5G. 2G. Yeah, it's 5G and then V. We'll go G. 25. No, that's not how it works. So 5G and then we'll just do this. Trying to. Oh, I got it wrong again. I'm trying to get shortcuts on Vim. It's still difficult. All right. So here's the idea. What we're gonna do is res equals to sum n for n in nums if n is even. So we have original one, and then for query. So query is value and index. So for val, I'd call it for delta and index in queries, right? So what we do is we're gonna check if, right? We're gonna follow our thing. Probably easier way to check. It's not a really easy way to check. So if nums index is even and delta is even, then res plus equal delta. If nums is even and delta is no, that's fine. Num is even and delta is odd, right? Num is even, delta is odd, then we say res minus equals to nums index. If nums is odd and delta is odd, so both are odd, then rest plus equal to nums index plus delta. Alright, and that's it, because the last one is num is odd and delta is even, that one is ignored. But at the end, nums index plus equal to delta, and then we return rest at the end. Okay, so test case. Oh, what are you doing? Rest is supposed to be a S is this. This is an S. So these are all S, right? Once we do this, we just rest dot append S and return rest. Okay. So we have 1, 2, 3, 4. Oh, we gotta copy this. Copy this. Query. Okay. Second one is 1. Query is 4, 0. What's the answer? Answer is 0. I didn't put the answer. Answer is 8, 6, 2, 4. Okay. Okay. All right. This one going to be nums and queries. This is going to be sum nums queries. Run it. All right, both pass. I think it's right. We can just submit it. Okay, so we do this console. Yeah, just give it a shot. All right, now we test it. All right, good. We hit 5. So this is not a medium question. It's easy. It's a hard easy, right? It's a hard easy, or an easy medium. So there are 4 situations to evaluate. Nums index is even. Let's say here. 1. Num index is even. Delta is even. So in this case, simply add delta. Nums index, I can just copy this whole thing. So num even, delta is odd. Remove nums index, because this value will turn into odd. So this is this one is odd, and this is even, and this is odd. Add nums index plus delta, because we have created a new even number. And the last situation, this is odd, this is even, ignore. No change to sum. On is every query where, it's actually on plus m, where n is the length of nums and m is the length of queries. And we run at 508 or 81. Okay. Oh, it has solution. Maintain array sum. And for this, if it is an even number, we always remove it. We plus this, if this, and then, okay, this is easier. is easier? Yeah, this is an easy question. Well, basically, we tried to find a medium one, but got hit by an easy. But it's I like the actual solution. It's better. It's cleaner. It's cleaner, much cleaner. So I'm gonna put it here. This is the official solution. Much cleaner in logic. So let's put the link. All right, we can write it ourselves. Doesn't matter. So we do the same thing. Basically, just copy and paste the entire thing, but we make slight changes, right? So blah blah blah, and then we're gonna say if this is this, if original is this, then we're gonna say s minus equals to nums index, and then nums index plus equal to delta, and then we're gonna check again, right? And check again. If it's become even again, then we're gonna add it, and then we do this, and then we try this. Oh, what happened? 8, 6, 6. Huh? If it's odd, right, and I remove it, and then I add delta to it, and I check if it's still even. If it's still even, then add it back. Oh, I added twice. There we go. Okay, so this is the official solution. Let's just go for it. I think it'll be faster because we only have 2 checks instead of. I was going to say it'd be faster, but no, it's not. Yeah. All right, that's it. So we did 2 today. Both actually pretty easy. So this one's what, 985, if I remember it correctly. 985, yeah. So LeetCode 985. All right, that's it. That's it for today. I will see you guys tomorrow. Adios.